Good day, ladies and gentlemen. My name is Willem Low, like you just heard. I represent and work for Evosoft as a software architect. I've been with Evosoft now for going on close to 3 years. At least 2 of those years I've been focusing primarily on MindSphere-related apps. And as a software architect based here in Nuremberg, my primary focus is working together with software development teams in order to build customer-centric solutions. Now, please forgive me, I'm going to keep the formalities very, very short because we've got quite a lot of material to cover in a rather short period of time. So, without further ado, let's jump then into what we are to talk about here, and that is our SOA, or so-called self-optimization application. Now, if you've been to our stand at the back, one of the very recent events, you might have seen this model, this hardware model before. It is because we like to use this model and showcase it because it actually gives a tangible aspect to our simulations and demonstrations. For the benefits of those that have not seen how this works, I'm going to briefly explain what you see in front of you. So let's move on quickly over there. First of all, we have a feeding station that feeds so-called vessels onto a closed-circuit conveyor belt. These vessels make its way around the closed circuit, often several times at the end of the day, and they will keep lapping the circuit until they are being processed by one of these workstations on the left-hand side, station 1 or station 2. After processing, the vessel is placed back onto the conveyor belt and makes its way to the sorting station, where it is then taken off of the conveyor belt. Now, what does processing really entail? In this case, it's quite simple. The vessel drives into a workstation, it puts an inlay into this vessel, and it then seals it off with a colored lid. Nothing too complicated. What is very important to notice right here is that there are 3 lids or 3 color combinations for the lids. A white and red combination can be processed by the first station, and on the second station you only have the option to process blue and red grids at the end of the day. So let's talk about our problem statement. The problem statement is actually quite simple. It means we want to optimize, we want to create throughput at the end of the day, and that would be our goal as well. In today's environment, time equals money. Any form of loss of time equals a loss of revenue for us at the end of the day, right? So the more efficient we work, the faster we work, the more money we can save at the end of the day. And that's why that is exactly what our goals are. We want to identify delays in production and we want to optimize these goals. Now, we have several constraints at the end of the day, so let me briefly discuss and explain to you what those constraints basically are. Now, if you think back on the model that I showed you, a workstation, first of all, can only process 1 job at a time. Second of all, a workstation can only accommodate 2 of the potential colors of lids, even though there are 3 colors available. Now, there's a little bit of a glitch, and this is a little bit more technical. Basically what it entails is shortly before a vessel enters or passes by a workstation, there's a very, very small margin and a window of opportunity where we have to ascertain if this vessel can be processed. It means, does this workstation have the right color lid available? And second of all, is this workstation vacant right now? If these conditions are not met, the vessel continues its journey on the circuit and will obviously lap to make a second or a third, and sometimes in worst case scenario, a 4th attempt at a later stage. Now, just hearing that should make the hairs on the back of your neck stand up, because that equates to loss of revenue and wastage of time. So, the solution, ladies and gentlemen, is actually pretty simple if you think about it. If we talk about it in the normal language, it's actually straightforward. We need to do 2 things to optimize this entire process. First of all, we have to make sure that both workstations are working 100% at optimal performance. That means the one station can't do all the work and the other station lies dormant. How do we ensure that? we will have to resort some of our orders to make sure that both stations are occupied. It means we have to process tasks in parallel. The second thing that we need to do is when we feed the vessel onto the closed circuit, we need to time it exactly to make sure that when a vessel arrives at the station it's intended to process, that there's a very, very high chance that that vessel will actually enter the station and be processed without continuing and lapping the circuit on the outside. So, we're going to move on and show you how we solve this problem. So now it gets a little bit into the nitty-gritty details. So for those of you who are not really technical, bear with me for a second. We took the model that we have here in Nürnberg and we connected it using a nanobox. Now, I would like to stop there for a second and say we had two great advantages of the nanobox. The first one was it was really easy to configure at the end of the day, so that is a definite plus. And second of all, you can rest assured, the nanobox gives you the functionality and the ability to pump your data in a secure fashion into the cloud. You don't have to worry about encryption and about security. The nanobox actually takes over this part of the job for you. So, off goes the data into the cloud, it lands in my time series service at the end of the day, and now what? So the first problem we realized is that at the end of the day, the data, we want to do machine learning, that's what we're talking about, right? But we learned that the data, we can't use it in this raw format. The first thing we have to do is we have to prepare the data. We have to prepare it and process it in such a way that it actually can be utilized for machine learning. So, we developed a processor using something called Python at the end of the day, and we extended that with something called a learner module, also developed with Python. The learner module basically, in very simple terms, takes the processed information and derives knowledge or derives and figures out which parameters in conjunction with which parameters yield the best results at the end of the day. To make this all tangible to the users at the end, we then implemented a Node.js and Angular 2 app that basically visualizes whatever we are talking about right now. It does another little fancy trick, which I'll explain in a second. And we then created another controller, which basically creates so-called machine instructions. It tells the machine or the system at the end of the day how to calibrate, how to improve its performance. Now, I want to hold on here for a second because I'm very proud of this feature actually. As far as I know, Evosoft is the only one out there at the moment that's actually doing bidirectional communication with the MindSphere cloud. We are pushing data up, we are implementing our machine learning modules to that, we are getting real artificial intelligence we're using there, and we're getting real information out there, and we are pushing that data back to our model at the end of the day. It means that over a certain period of time, our model is without human interference capable of calibrating itself and improving the throughput and the performance. So without further ado, I would like to start showing you a video of what this looks like in real life. I'm going to keep waffling to explain to you what you're actually seeing over here. On the left-hand side, you see the system basically before we implemented any of our machine learning options and functionality. On the right-hand side, you see it basically its counterpart, and that is after the optimization had happened. The biggest thing that you will notice is that the vessels placed on the closed circuit on the right-hand side, they never fully lap the entire circuit. They are placed in a slower frequency onto the conveyor belt, but therefore they go straight into the workstation, they are processed, and they come straight off at the sorting station again. On the left-hand side, if you notice, there are several of these vessels actually making its way around the circuit more than once. This is obviously a loss of revenue for us, a loss of time. It accumulates to cost. So I'm not going to show you the entire video. I just want to make sure that the one on the right-hand side, you will see that it finishes way in advance compared to the one on the left-hand side. And this is exactly the same jobs that had been fed through the entire system. So what I can tell you, with this implementation, we improved the performance with 30%. It means that a third of the production cost, a third of the energy cost, a third of the staff cost, a third of the time could be reduced by implementing this technique that we have shown you guys here today. So, the journey was long. The journey took us, I would say, about a year to get it all where it is today. And it was not without its hiccups. So we had a couple of challenges along the way, and we met those challenges head on. And I would like to tell you a little bit about those challenges. Now, first of all, correct timing and parameters. That was a major issue. Which parameters are valid, which parameters are not valid, which parameters and which time frequency do I need it, etc. Figuring out and calibrating the timing at the end of the day was quite difficult because it really boils down to micro milliseconds at the end of the day. So then gathering and processing the data was the next issue we had. We got all this data, we didn't know what to do with it or how to process it at the end of the day. So we had to learn how to take this data and transform it into such a way that it's actually usable. Then came the whole learning curve involved with artificial intelligence and machine learning. And believe me, that was a huge headache. But I'm proud to say that we've actually got a team of very competent individuals on board at Evosoft right now. The one gentleman sitting right here in front. And yeah, we've made this experience, we've learned, we've ramped up, we have the skills now in-house, and we've become the master of this quite daunting task at the end of the day. But I think one of the biggest things that posed a challenge for us was the diversity. We have so many diverse technologies involved. We've got so many, we see them down there, like Python and Node.js and Angular, and there's RabbitMQ and OPC UA, time series, APIs, REST, Cloud Foundry, authorization, etc., etc. And one of our biggest challenges was making a coherent solution out of all these various aspects. And that is where the so-called IT conversion comes in. Now, we've walked the road, we have made the experience, and I do believe you guys can benefit from the knowledge that we've basically acquired over the last couple of years. So on behalf of my team, I would like to thank you for viewing our presentation. And I would like to invite you guys, we are there in the back on the left-hand side. Please come and have a talk to us if you would like some more information about what we do. We have several very interesting use cases lined up. We are also very interested to hear what you guys are doing and what use cases you have and what challenges you are facing on a daily basis. So, thank you very much.